Okay, so in the final part of the lecture, we're going to be looking at finding the area of a triangle. So you will have been shown before that the area of a triangle is equal to the half times by the base times by the perpendicular height. However, not all triangles we're given the height for. So say we have a triangle that looks a non-right angle triangle a little bit like this, and we call it A, B, and C, and we're going to call our sides A, C, and B. But actually now we want to find its height to help us answer this question. So this is where we can make our generic rule. So if we do what we've done previously and draw a line and call this D, we can say, okay, so how do we work out this D? Well, there's two ways of doing this. We can either make it either a function of C, this angle C here, or of A. So in our case, we want to make it of A for this rule. So what we can say is, if we can find this our H, from this we need to bring our SOHCAHTOA in. So what do we need to be able to find our angle of part of C, or to find our H? So we need our H, which would be our opposite. We don't have an adjacent, so it's got to be a hypotenuse and an adjacent. An opposite and a hypotenuse would be sine. So we need to say that sine equals, or sine A equals our opposite, which is H, over our hypotenuse, which is C. So that would be H equals C sine A. And I've just told you that our area for a triangle is a half times the base times the height, which means that that would equal half times by the base times by C sine A. So that would be our new answer to the question. So that's quite simple, really. We'll have a look at an example. These are really important, and we'll talk more about this when we go into mechanics and when we look at integration. This is quite important for looking at the trapezium rule and understanding what's going on. Well, not use look and understand what's going on in the trapezium rule, how we do integration. So let's now move on to an example. So just do one quick example, and I might say in the exam, in the triangle PQR, given that P equals 65 degrees, Q equals 79 degrees, and PQ equals 30 centimeters, find its area. Okay. Okay, so if we draw our triangle, it looks a little bit like this, and we put our sides on, P, Q, and R. And then we start to add some degrees in. We'll put our little r in. So P to Q, this will be our side R equals 30. We'll call this P and we'll call this Q. And then we're going to add our angles in. So we can see that Q equals 79 degrees. P equals 65 degrees. Oh, we don't know what R is, but we can figure it out because we have our relationship where I showed you that 180, all angles in a triangle add up to 180, minus 65 minus 79 will give us our answer, which will show us R equals 36. So that's our angle here. And now we want to find the height. So we can do this one of two ways. We can either do it from P or from Q. So let's go for P. And we have the opposite, we're after P, so this means we can use the sine rule. So we can say P over sine P equals, well, we know what R is, R over sine R. So we'll fill that in, we'll say that P over sine 65 equals 30 over sine 36. And then we can then put this in terms of P, where P equals 30 sine 65 all over sine 36, which means we get an answer of P equals 46.26 centimeters. So we've worked out what our P is here, which is 46.26, and all we need to do is use the same equation that we've been previously shown. We have our Q here, we follow it round, so the area would have to equal our half times a base times by our C sine sine, our equation here is sine A, BC sine A. Okay, so we have our angle here. We can plug this all into our equation, sub in for what we would have. So that would be equals a half P times R times by sine Q, which means that it would be a half times 46.26 times by 30 times by sine 79, and that would all equal, if we put it into our calculator, we get 681.2 centimeters squared. So that would be the answer to our question with 1 decimal place. So that has been trigonometry. In next week we're going to move on. We're going to move on fast. We're going to look at some fancy sort of division. We're going to look in some calculus, and we're going to look at some differentiation.